Okay, everybody. The next way we're going to identify our linear, exponential, and quadratic functions is we're going to use differences and ratios. So far, if we've got some points, we can plot them, we can figure out what type of a graph it appears to be. But here's going to be a different way to kind of go about doing that. So, linear. If you have a function and you're given a table of values and it's a linear function, then the first differences are the same. And that will probably make more sense once we do it. If it's quadratic, second differences are the same. And if it is exponential, it has a common ratio. And again, if you forget what a common ratio is, we will go over that. Number 2, tell whether each table of values represents a linear, exponential, or quadratic function. Now, we're either going to use this idea of a common ratio or first or second differences. First thing we're going to check for is our x values. In order to do this and for this to work, your x values have to either be increasing or decreasing by 1. If they're skipping all over the place and something goes up by 2 and something goes up by 5 and something, this is not going to work. So when we're dealing with the table of values, -3, -2, -1, 0, 1, those have to be increasing by 1. Then we're going to go look at our y values and we're going to figure out what's going on here. So in order to get from, and I usually ask it this way, how do you get from 11 down to 8? So 8, 9, 10, 11, you would subtract 3. How do you get from 8 to 5? You would subtract 3. How do you get from 5 to 2? You would subtract 3. How do you get from 2 to -1? You subtract 3. This is called the first difference. And if the first difference is the same, that means we have a constant rate of change. The constant rate of change is -3. Down 3, down 3, down 3, down 3, which means this is a linear set of, a linear table. It's going to represent a linear function. Letter B. First of all, check your x values. -2, -1, 0, 1, 2. They're going up by 1. We're good to go. Okay. How do you get from -1 to -2? You go down 1. How do you get from -2 to -1? You go up 1. How do you get from -1 to 2? You go up 3. How do you get from 2 to 7? You go up 5. Now, this is the first difference. Are they the same? No, which means it's not linear. Okay, these are not the same. This is not a constant rate of change. Something's going on here. And this again is your first difference. So we do it again. How do you get from -1 to 1? You go up 2. How do you get from 1 to 3? You go up 2. How do you get from 3 to 5? You go up 2. This is your second difference because you did it a second time. If the second difference is the same, that means that this is quadratic. Letter C. Okay, once again, -2, -1, 0, 1, 2, our x values check out. Now on this one, I'm looking at it and I'm going, okay, 1 to 2, I go up 1, then I go up 2, then I go up 4, then I go up 8. What is happening between 1 to 2 to 4 to 8 to 16? And at this point, I could try to do my differences, but I don't want to waste my time. So in order to get from 1 to 2, you multiply by 2. Well, how do you get from 2 to 4? You multiply by 2. 4 to 8, multiply by 2. 8 to 16, multiply by 2. So this is not a difference at all. Difference means subtraction, or you're adding or subtracting to get somewhere. This is multiplication. So this right there is your common ratio. And if a common ratio exists to get from the first to the second to the third, etc., then this is exponential.